Well, the red grouse is one of the commonest birds on the heather moorlands of Britain and Ireland, and at one time was thought to be a species unique to that area, but it's now regarded as just a subspecies or race of the circumpolar willow grouse, which lives from North Norway through northern Russia to Alaska and Canada. It got cut off in Britain after the Ice Age, and the willow grouse then adapted to the milder conditions by no longer turning white in the winter time. The red grouse, you see, is dark in colour all year round, very well camouflaged on the moors, still a trace of white on the feet and under the wings, but a bird which shows its Arctic origins still, with the heavily feathered feet right down to the toes, very, very thick feathering in here, because it spends the night just out on the open here. You see the claws are long, and it uses these for scratching through the snow to expose the heather that it feeds on in the wintertime. It's the main economy on millions of acres of moorland in Britain and Ireland, and it's the thing that gives local employment. It also brings in a lot of foreign exchange. And we were brought in because the numbers of grouse shot on the moors in Scotland had gone down greatly since the Second World War, and the landowners were not getting money for the shooting, or not getting as much money as they used to, and they wanted to know why that decline had happened. Well, in the first place, the Scottish Landowners Federation asked for the research to be done, and they put up the money for 3 years of research, and later that was taken over by the Nature Conservancy because they thought it was producing a useful study on basic population dynamics of an important animal, and also because the grouse was at the heart of the whole moorland ecosystem and the continuation of that ecosystem in Britain.
Our early tools in this study were very simple ones. You could say four-wheel drive and a good nose.
And we found the best method for counting was to use trained setters and pointers, which can range around on either side of you and will smell the birds and flush them when you want them to do so. This we found gave a total count of all the birds present in a given bit of moor. The dogs were useful as well because they found the nests. Grouse hide their nests in the thick heather, and you can walk for a whole season sometimes and not see one, but the dogs find quite a number of these. They were also good for finding dead birds. We were able to find about half the birds that died in the area, which is very good, and for finding the chicks as well. Well, besides counting with the dogs, we marked the birds so that we could tell them individually, because we realized it wasn't enough just to know the numbers born and the numbers dying and the numbers on the moor at any given time. We also wanted to know who was who, because we could see that the grouse was a territorial bird, and we could see that some cocks defended much bigger territories, bigger areas of heather than others, and we could see that when the numbers were coming down, cocks were taking bigger territories, so it seemed that social behavior of the birds was important. And to know which bird was which, we had to have them marked.
But we had to catch our birds first, and we found the best time to do that was after the harvest in the stubble fields. Birds on the lookout for stray oats walked straight into simple wire traps that we'd placed round the stooks. But to identify individual birds at a distance, you need a marking technique much more conspicuous than just metal leg rings. Ray Parr, one of the team, spends a lot of his time marking grouse with plastic numbered back tabs. They're fastened on with a harness around the base of the wings. We can read the individual numbers on each tab about 50 yards away through a telescope or binoculars. And the birds aren't bothered by the harness when it's fastened and adjusted properly.
The main thing we'd concluded was that the grouse were controlling their own numbers, and they were doing this by redistributing the territories every year in the autumn. Now, the interesting thing was that not all the birds got territories at that time. In fact, large numbers didn't. And these birds we called non-territorial birds. They fed on the moor, they tended to be in flocks. They were continually trying, many of them trying, on the territories. They were challenging the ones that were already there, but usually failing. And over the course of the winter, the mortality that we saw, which was heavy, due to birds being killed by predators, hitting wires, and so on, this mortality was falling almost entirely on the non-territorial section of the population. Now, the next thing was, would these birds be capable of taking territories if the ones that were established weren't there? So we did some experiments on that by shooting territorial cocks and hens and seeing what happened. And the result was very interesting because the non-territorial ones, which previously had been surviving badly and didn't have a place in the sun, were able to take territories, and from then on their survival was very good. So there was nothing inherently wrong with them. It was just that they weren't dominant enough in the first place and aggressive enough to take a territory. Eventually we realized what was happening, and we saw that the grouse had an ability to go up and down in numbers even if the food stayed the same. That was very interesting. And it became quite clear that the grouse is one of these cyclic animals, like the lemming or the vole, only a longer cycle. And that these cycles are fairly regular, not absolutely regular, but more regular than you would expect by chance. And that the birds have this ability to reduce their numbers in relation to crowding. And we found that they did this by emigrating and by taking bigger territories. Well, it seems to be an inherent change in the bird's behavior. During the increase phase, they're fairly tolerant and they allow numbers to come up. But something at high density triggers off behavior which succeeds in reducing the numbers. And this can take place by the birds taking bigger territories. It also can take place by having a changed sex ratio in the territorial population, so that instead of the ground all being divided up by cocks, which all have a hen, you can have perhaps 3 cocks to 1 hen, so most of the ground's occupied by bachelors, which is a very good way of population control. And the other way is by emigrating with the chicks and leaving them some other place before coming back themselves.
The grouse research became part of the program of the Institute of Terrestrial Ecology, and hypotheses about population fluctuations derived from field observations could be tested experimentally. Young birds reared on the moor by grouse parents that held different sizes of territory were compared with young reared by domestic hens from eggs taken from the moor. Experimental and biochemical aspects of the study were the particular responsibility of Robert Moss.
Well, the birds are not obviously limited by factors other than themselves for much of the time. They seem to be limited by the size of the territories they take, and the size of their territories they take is related, at least in part, to the level of aggression which they display. And this varies throughout the fluctuations, and we're testing the idea that the innate level of aggression varies throughout the fluctuations too.
The signs of aggression are very obvious. Tail feathers splay. Red combs over the eyes become prominent. And the grouse has a large repertoire of display calls. But quantifying the level of aggression is much more difficult. What's recorded in the field is not exactly aggression, but really it's the interaction between individuals, the relative dominance of adjacent cock grouse. Each cock can be given a score which is related to aggressiveness and depends on the size of its territory, the number of combats it has, and how successfully it fights. Now, from this information alone, it's not clear whether aggression causes differences in territory size or territory size causes differences in aggression. But this was tested experimentally by implanting birds with male sex hormone, testosterone. The implanted birds' level of aggression increased, and they enlarged their territories.
We have a sort of dialogue between the captive work and the field work. In captivity, we can study things in much more detail under much more controlled circumstances, but we're never quite sure that it's precisely relevant to the field. We can measure the aggression of captive birds quite simply by putting the birds in a run and seeing who dominates who.
But at some times of the year, it's not quite as simple as that. Sometimes there's little obvious sign of aggression, perhaps only a turn of the head or a brief call. At other times, the interactions are much more dramatic. A cockbird with erect combs launches into a display. And then it subsides, its activity recorded.
Now, the big problem here, of course, is demonstrating that aggression in captivity is similar to the aggression observed in the wild. Clearly, the circumstances under which we measure them are quite different.
But experiments in the run have shown that captive birds implanted with testosterone increase their aggression and social status too, and in a similar way to birds implanted in the field.
And my original hypothesis, which we could call the nutrition hypothesis, was that essentially populations which were less well fed displayed more aggression, took smaller territories and therefore lower in density. This is probably true, but it's probably only part of the story. What one essentially sees is that the equilibrium density round about which fluctuations occur is related to nutrition, better nutrition, higher equilibrium density, plus variations in nutrition which are due to poor weather or changing management or something like this, do cause changes in grouse numbers, but these are superimposed on this cyclic effect. And although grouse only eat perhaps 2% of the green food available to them in a year, nonetheless numbers are in fact related to the food available. And the idea that we've finally come up with is that they are related to a very small proportion of the food which is of much better than average quality.
Analysis of the chemical composition of heather and experiments on how much was digested by the grouse suggested that protein and phosphorus were the nutrients most likely to be in short supply, to be limiting factors in grouse nutrition.
To check this out, we used a completely different approach to assume that the birds knew what was good for them and to see what they selected from what was available. What we did here was to define where they were feeding take their crop contents and compare the chemical composition of the crop contents with the chemical composition of the green material from the heather where they had been feeding.
The results showed that both protein and phosphorus were selected for by the grouse. The heather tips in the Petri dish have a higher concentration of nutrients than in the rest of the plants.
The heather food was very important for the populations of the bird. There were more grouse in places like this, which are heathery, than where it was grassy. There were more grouse where the heather was growing over rich rocks, where the actual shoots might look the same to you and me, but they were chemically richer.
Grazing pressure from sheep and cattle reduces the amount of heather and promotes growth of grass.
You can often see this very well along a fence line where the sheep and cattle will be concentrated on one side and there's very few on the other side. Often in these places you'll see pure sward of heather on one side of the fence and very short heather with no grouse on the other side.
We did quite a number of experiments. One of the main ones was to fertilize it, because that way you get quite a dramatic increase in the nitrogen content and in some cases the phosphorus content, depending on which fertilizer you use. And we did experiments on that which showed that the grouse would take smaller territories and rear larger broods. And so this confirmed some of the points we'd already observed by just looking at the population, looking at the heather.
As well as young, high-quality heather for food, grouse need old, tall heather plants for shelter, and cocks compete to hold territories that include heather of different ages. Territories don't overlap. This is very clear in snow, where tracks show that two neighbouring cocks have displayed along a common boundary with only a narrow corridor between them. Managers of grouse moors periodically burn acres of old heather to promote new growth, the dark strips of moor below. Plotting the edges of the cock's territories gives a jigsaw pattern, and the smaller ones are in areas with mixed-age heather.
We did an experiment taking a piece of moor which hadn't been burned for a long time, and where the heather was about 20 years old or so. And on that moor we burnt lots of small, narrow strips and had a control area nearby that was tall heather. And within about 3 years, the grouse numbers had built up. In fact, we doubled the population on this experimental area where we put in the little strips. And that showed quite conclusively that burning had quite a dramatic effect if it was done properly. They build up numbers very rapidly because the grouse can rear very large broods, and something like 6 or 8 young. So they have the potential to go up very fast. They can double numbers within a year and rise to very high density and then come down again. Now, what we found in the most recent decline was that the birds can reduce their own numbers even if food is all right. And we fertilized an area to see if we could stop the decline, and it didn't make any difference. So in the end of the day, we conclude that food has a major effect on grouse numbers and can reduce grouse numbers, but that the grouse has an inherent ability to reduce its own numbers in relation to high density, even if food is all right. We suspect that there's an advantage to the bird at peak numbers in being aggressive, and the ones that are aggressive do better. And if they can survive through the decline phase and then be around at the trough, that's the time when it's the best time to be there, because a high proportion of that bird's chicks will get territories. So in evolutionary terms, we think that's probably how it operates, although of course that's speculation really.
The research on red grouse populations has lasted more than 30 years. The Scottish landowners have been given advice on moorland management. But the years of careful observation of what the birds actually do have yielded more than this.
Well, I hope that we can abstract from the grouse study to contribute to a general understanding of population dynamics. In particular, a very simple system heather and grouse essentially, seems to throw up a situation where there's a lot of factors affecting grouse numbers. Perhaps the most useful contribution that we made, I think, is to show that the population itself, independently of extrinsic factors, can cause its numbers to change, and that one needn't necessarily look for an external cause for every change in numbers.
Many people have a romantic idea about the kind of work that people like me do. And on a nice sunny day, it's nice to be out on the moor. But to do good research, you've got to have a commitment to continue doing the same thing in a routine way and building up data and analysing it and eventually writing it up, because there's no point in doing research and just for your own pleasure. And that requires really a lot of discipline. And you've got to enjoy or even love that discipline. And I find when I take the average person out, they'll be interested in going, just briefly. And if you're walking on the hill with dogs or something, that's interesting. But if you're showing them behaviour from a Land Rover and you're watching grouse through binoculars, they'll very quickly get fed up with it. And bored stiff, in fact. And so they wouldn't like to do this kind of thing. I usually get up to doing some research thing or other. You know, I just have a tremendous curiosity to go out and look at nature, and if you see things that other people haven't noticed, I just get a great kick out of it.
Well, since that programme was made, more recent research, notably by the Game Conservancy, has emphasised other explanations for the regulation of grouse populations. But there's no consensus of opinion, and the subject is still a matter of debate.